Yes. Yes, we're good.
Perfect. Hi, everyone. We are non-invasive tissue imaging team. I'm Shatich, and we are working on the onchocerciasis or African river blindness. So basically, it's a filarial infection caused by a nematode. In fact, one of the 9 worldwide nematodes, in which humans are definitive hosts. One of the main presenting features are subcutaneous nodules, which we'll see in the follow-ups. And these nodules, if in turn by ocular manifestations, if left untreated, can lead to blindness. It is second leading cause of the blindness due to infection in the world, and at least 20.9 million people are infected worldwide. The infection is found in tropical climates, and with the main burden of the disease concentrated in the 31 countries in sub-African regions. This is the transmitter, the black fly, which is found in the certain endemic regions of the fast-flowing river waters. And this is the nematode that's inside the fly that infects the most of the time. And once bitten over the next 6 to 12 months, they develop into a mature adult parasites. And this is when the observable signs come up, which we will talk about next. And the most common infection medium is by insect bites. So these worms typically avoid immune system by hiding in the nodules of the skin, where they grow and they become lumpy. If these inflammation increases and these nodules are left untreated, then they turn into itchy skins and sclerosing keratitis and skin nodules. Current diagnosis systems include invasive methods, which are typically taking the skin snippets and observing them under the microscope, or other serological tests. This is one of the examples of how the snippet is taken and is observed. I would recommend everyone watch this. It's a good series where they talk about different worms and how they infect. I'll just show you one of these small videos.
When he came into my office, I immediately recognized that he had a swollen hand, arm, and upper arm. He also complained of some itching and rash.
So if you observe that the observable symptoms are typically that we discussed: itching, rashes, and swollen arms. And the first diagnosis that the doctor does is,
before I knew what was going on, he took a sample of skin with a little device that took a snip out of the surface, and he stuck it under the microscope.
So this is something that is the most popular method of diagnosing if there are worms inside the skin or not.
I know what you have.
I think Geza was quite surprised that a diagnosis could be made just on observation.
Dr. Wolf invites Geza to take a look for himself.
I look into the microscope, and there are these funny little worms crawling around. And he says, well, you've got river blindness.
So this is interesting, that what we observed till now is that, of course, this can be identified just by observing inside the skin nodules with the presence or the absence of worms, and does not require a lot of blood tests in order to identify whether there are infections or not. But since we wanted to do non-invasive testing, as we are the non-invasive tissue imaging team, we went through different non-invasive methods to understand the skin properties and its impedance and its mechanical strength properties, and can we actually exploit those changes in order to understand the next coming up things that are happening due to the infection. I think Indumita will explain the electrical impedance spectroscopy.
Yeah, so one of the methods that we explored was electrical impedance spectroscopy. And this works by applying a small alternating current to the skin, and then you measure the resulting voltage. And what you do is you change the frequency. So higher frequencies penetrate deeper. So by this way, you can get different layers in the skin. And so you can go from the top of the skin, like low frequency, and then high frequency going deeper. And then when you measure the impedance at these different layers, it can tell you a lot about the skin's properties. There have been a lot of models, like lumped capacitance models. Oh, sorry, next slide.
You want me to stick on this slide, or you want to move?
Sorry, next slide. So there are a lot of lump capacitance models which can be used to model the skin, and we need such models because it's hard to differentiate between what is the normal skin impedance properties versus what it would be if we had these parasites inside the skin. So in order to differentiate between the two, we need to be able to model the normal skin properties. Can you go to the next slide? So this is, as you can see, a very complicated model, and it shows like the different layers from all the way to the top to the bottom. Can you go to the next slide? So with this method, there are pros, but there are also a lot of cons as well, because the microfilarial stages that can be detected because it's much higher up in the like skin layers, but the adult worms reside deeper in the subcutaneous tissue, and this method might not be able to reach that far with there'll be a lot of noise, so we can't really say for sure whether it's present or not. And also there are a lot of issues about like safety for like current voltage limits, like heating, that sort of issues as well. So we looked at this method, but we kind of also explored other methods. And the next method we explored is using mechanical indentation. So I think Kamal will talk about this one.
Yeah, so I think I discussed this briefly in the class where we were trying to troubleshoot which direction should we go in, and this method essentially utilizes the property of using external force and then measuring the shear modulus or elasticity using a force sensor. So there is a very expensive model which is sort of available to the Western world and costs like almost $4,000, and it's a handheld elastimeter, and you could basically measure the elasticity. And as this graph shows, you can draw some inferences very clearly, because many methods have already characterized this, that as we age, the elasticity sort of reduces, and so this shows that there is some truth to that, and that can be detected by many methods, and so it's sort of verified. The only problem being accessibility, as this costs like something upwards of 4,000 USD, so it's not really easily accessible, and you can't provide this to everybody or say in schools where you have millions of children, where you want to screen this, because many of them got nodules not because of the worm or the fly infecting the worm, but because of other reasons. And as Kshitish has pointed out, like the nodules look really similar, so the mechanical properties could in principle change because of many reasons. So that's the key challenge, I guess, with the method that we have. But there's something that has been done. On the next slide, this is like one model that we came across, which is fairly recent. This paper came out in 2020, I think, and they made a DIY force sensor coupled to, so basically they have these components. One of them is an actuator, and that is the other one is the force sensor, which is basically controlled by a microcontroller. And then the blue part here sort of shows the indenter, which is basically now pressed on different parts of the wrist or body. And you could, and since this is modular, it has like 5 screws, you could essentially have multiple attachments go in this place. The only catch being, again, they used it for showing that the anterior wrist versus the posterior wrist, there's a hell lot of a difference which you could detect, and so naturally it becomes the range to explore. And it's also useful to mention here that the range of the elasticity that it can range between ages and different parts also falls in under the same sensitivity. So in principle, you would imagine that this could work. The only thing that we need to now do is to be able to find out a force sensor and check whether we could measure very small differences. And one idea that Manu gave us on Monday, and we haven't been able to get a force sensor so far, we haven't made any measurements, but he suggested that we could sort of do these measurements on a mosquito bite. And so some of those nodules that Kshitish had shown earlier, in the initial stages, they are not as big, and only when they swell up enough and there's discoloration, that you can begin to think that it may be more serious than what you imagined it to be in the beginning. So I feel like starting at the mosquito bite may be worth pursuing, and so we have Indumita, who's trying to get a board for taking some measurements in her lab using the impedance based method, and I'm trying to get a old weighing scale where we can hack it to somehow make some measurements, but we haven't been able to do that so far. So that's all that we have so far. This is something that, yeah, there's a few possible designs. There's one of the designs that Indumita scribbled. Yeah, so maybe she would
Yeah.
like.
This was just a fast sketch, but I was thinking in the realms of like a pizza cutter basically, but you just like roll it against your arm along the bumps, and then you could have like modular, like so you can change the size and the shape of the probes on the end of the rotating wheel, and then you can create like a profile of like the bump elasticity like along the skin. So this, like in the same measurement, you could get the change between the normal skin elasticity and the elasticity of the bump as well. So it would measure the change, so that it could always be relative to the patient. And then I was thinking have some electronics inside and some LEDs. Maybe we'll have like a threshold for example, if it's this difference, then then there's onco. So it's something just really fast, so you can just like roll it along your skin. I know Manu mentioned like a ballpoint pen. So just something, I just thought of that, something quick like that. But yeah, we haven't been able to make any measurements so far.
One of the other thing that I was thinking was about trying to understand if we could use some pitting edema techniques to understand the nodules strength. So if it's some, let's assume that there's some amount of force that we can push in and make a mark on the skin, and how does it vary and can be on the nodules that are for the onchocerciasis, and that are the other ones that which are come from the healthy skin. And if we can calibrate these two, I think this with the same force, it could be one way of doing without any much of a electronics. But this is just still into a very rough idea that we could think of initially to understand how we could do it, just coming from the fact that skin has some basically the inflammatory tissue has to have a different elastic properties since it's already stretched compared to a normal healthy skin. So yeah, that's it. Thank you.
Thank you.
Since we are at different parts and none of us got to be in a place where we could get some instruments to work, so we are still motivated, and both Indu and me are soon going to be in Oxford, so we still plan to continue this collaboration, and we hope to make some measurements.
Yes.
Oh, sorry, we can't hear you.
Can't hear you.
You
Manu, we
Manu,
can't
sorry.
hear you.
I'll say that to Maria. Any last minute question? We have one more.